Okay, thank you very much. I'm going to be using the handheld mic because I'm actually too short to see anything. So I'm going to be going over ticks, basically tick biology, and I'll touch on, as I speak, some background, and then talk about recent research as it relates to prevention, early treatment, and diagnosis. And I'll end with a few comments in the spirit of people working together to come up with a solution to the huge amount of suffering, pain, and deaths that are happening due to Lyme disease. And I want to dedicate this talk to Brenda Sterling Goodwin. So for some background into the biology, this is going to be quick. There are ticks here. Most people have noticed, particularly in this part of the world. There is bacteria here. The Borrelia bacteria is the Lyme disease bacteria. If those two things were separate, it wouldn't be a problem. However, they don't stay separate. One of the things that makes more ticks are deer. Ticks can feed, particularly the blackleg tick is a generalist. It can feed from many different animals. So it's not just deer, but deer are an all-you-can-eat buffet for ticks. What makes a lot of Borrelia are mice. Mice are the bacteria's going to Florida solution to the maritime winters. So if the tick is going to freeze, the bacteria doesn't want to freeze in it, so it spends the winter in a mouse and then goes back in a tick the next year. And once you have this problem where you have ticks, lots of ticks, you have infected mice, the ticks get infected, and those ticks, those infected ticks end up on our pets and they end up on us. And then we end up with these horrifying situations, unfortunately from this part of the world, where you have a lot of ticks on people. Okay, so I'm not going to go into the details of how ticks feed, so we're going to skip that movie to save time. I'll just point out that they do feed, and they suck your blood and trade you for whatever bacteria is in their salivary gland. So it's really not a good trade. So in terms of what's happening in the future, Dr. Cram mentioned the role of climate change. This is a map of New Brunswick. Our current situation, all the red area is tick endemic area. That's in 20 years, that's in 50 years, and congratulations, Nova Scotia, you're already there. So, ticks are here, ticks are a problem. Now, my lab does a lot of tick testing for research purposes. We're supposed to be just testing ticks from New Brunswick, but we're right on the border, so we get Nova Scotia ticks. And it's usually both easier and more compassionate to test them than to send them back and say, sorry, too bad, you live on the wrong side of the border. So over the past 5 years, we've tested several hundred ticks from Nova Scotia, and I'm going to present 2 slides of the data we have. The first one just shows what types of ticks are found feeding on people, and about 60% of the ticks we get from people in Nova Scotia are the black-legged ticks. Now, what's important about that is that means about 40% is not, and when it's not the black-legged tick, it's almost always the American dog tick, Dermacentor variabilis. And what's important about that is those are not a Lyme disease pathogen. So that means 40% of the people who are panicking because there's a tick on them don't have to panic. So if you had a province-wide tick ID service, 40% of the people could very quickly breathe a sigh of relief and be peeled out of the medical system. Okay. However, for the ones who do have black-legged ticks, not every tick is infected. The chance of the tick being infected depends where you are. So for northern Nova Scotia, this is Cumberland County, right on the border, they're hovering about 20%. Pictou County is 5 to 10% more, and you guys down here are 40-ish%. So another thing that would be handy is if you find a tick on you, you're getting to close to even odds that it's infected. On the other hand, you might be lucky. So tick testing is very useful. So that's going to be, I'm going to come back to those points, but very quickly, if you're interested in this data, it's all available online. I'm not going to talk about dogs. I'm not going to talk about horses or cows or wildlife, including dead porcupines. If you're concerned about Lyme disease in porcupines, we'll talk about it later. I'll also mention that we have problems with lots of exotic ticks showing up here. Okay, so in terms of the ticks that are here, they are here. They're not going anywhere unless we drop a nuclear bomb on the Maritimes. The ticks are here. There's no biologically feasible way to get rid of Borrelia, much as we might like to wish them into oblivion. So they're here. So that means we have to peel people off. What's shown here is the pathway of tick disease, tick-borne fever, tick-borne disease, where people are here, ticks will feed from people. If we can prevent that, we peel them off the disease pathway. If you can catch and treat early Lyme, you peel them off the pathway. If you treat late disease, again, they're peeled off. What we don't want are people basically not getting dealt with. So there are a bunch of components to this. One is surveillance, the other is prevention. Many of our other speakers have mentioned prevention. There are good booths outside. I'd encourage you to look at those. For early detection, you have tick ID and tick testing, which I've mentioned. And for treatment, one of the things we need to do is look at modern diagnostics. And while diagnostics do need to be validated, we can't just stay with, we will keep using what we have always used because that's what we always used. Science does progress. In the interests of saving time, I'm going to skip surveillance just to say that I was very glad that Dr. Cram talked about the fact that our surveillance numbers are not completely accurate. We'd like it to be accurate. The question is, are the people who are not being counted, are they being treated and not documented, or are they not being treated? It's not controversial that they're being underreported. How much is something scientists are busy debating. For prevention, I'm going to skip that other than to mention that the information, it's important to be very accurate in the messaging. There's good documentation that ticks can transmit it under a day, so the messaging does have to be correct. Tick ID and tick testing, I've mentioned. It's useful for tick identification options. You have relatively few options right now. DIY is actually probably your best bet. If it's got white on the back, it's more likely to be a dog tick than a deer tick. And if you're not sure, take a picture of it and send it to me. There is eTick, which is available through most of Canada, not Nova Scotia. The workaround is to say you're from New Brunswick, but put in your actual home address, and we'll peel you out of the database later on, but at least you get a tick ID. Or you can just skip the queue and send it right to me. When you send a tick picture, could I ask that you send me a picture of the tick and not a beautiful picture of your hand with a little black tiny dot? For tick testing, basically you're looking at commercial options. I've got a little red circle around genetics because I share lab space with them. There's no financial commercial interest in there for me. They also have a booth outside. I'm promoting them. Yeah, I guess I am promoting them. They're Canadian, so your tick doesn't get seized at the border, plus you're paying in Canadian dollars. Okay, if you really care how we do our tick testing, we put a video on it. It's on the website. Go watch at your risk. For diagnostics, there are a number of different Lyme disease species, and they're not detected by the current serology, which is what Dr. Lambert pointed out earlier on. And for our diagnostics to work, we need to be able to detect what's actually here. So the question is, what's here in ticks? We do have Borrelia miyamotoi. It's increasing in frequency. We have Borrelia basseti. It's still rare, but I would predict it's increasing. Ask me in a few years. We have some of the European Lyme disease strains, so far just on remote offshore islands, but that is a concern. And ticks, it's not just Borrelia that are in ticks. Ticks are big, nasty, well, tiny, nasty crawling bags of pathogens. And this is a study that shows it, and we're going to go very quickly. So the comment I'll make on diagnostics is that the current approach we use, the serology, it's the backbone of medical diagnostics, but it is not a fresh, bouncy new technology. The ELISA is about to celebrate its 50th birthday. There are other options out there. Many of them have been well researched. The new ones have not yet been thoroughly validated. There's a very complex process of clinical testing, and that's absolutely critical to make sure that the test is working as it should, in both in terms of sensitivity and specificity. But that won't happen if there's a climate of we're not going to do anything different because it might give us different answers. So there are new diagnostics out there. Right now, the commercial sector is developing them quite quickly because it's more flexible. I would encourage researchers and practitioners to have an open mind towards this technology. Not everything new is bad. So I'm going to end with a few statements and then a suggestion about how we can move forward. The ideal situation is there are ticks, there are people, we're going to come in contact with each other, so we're going to try peel people off this pathway of tick-borne diseases as quickly as possible. So this is what we want, this is what we do not want. To summarize, there are lots of opportunities for disease reduction through prevention. The prevention methods do have to be grounded in good science. The messaging also needs to reflect what people are seeing in communities, because otherwise it lacks credibility. And unfortunately, because prevention will never be completely effective, we need ways of identifying ticks, we need ways of testing ticks. An ideal situation that's happening in the rest of Canada is coupling tick testing to treatment, and that's being driven by pharmacy associations, which is a really nice and innovative way to deal with early Lyme disease. In terms of late Lyme disease, the diagnostics do have to detect what's here, which means we have to study what's here, and we want to detect all the things that are in ticks, not just Borrelia, and we need to appreciate the complexity of tick biology. And so for my final thoughts about how we move forward, I think that it's critically important to take the patient, the experience of people, experience of communities into account. That's where reality starts, and we build from there. At the same time, by the time you end up at the rarefied levels of doing science, the science has to be done well, and there is the capacity to do that. And then the science also has to be reported accurately. And that's a challenge I would throw out to the tick-borne expert group. There are statements there that are not factually correct. You need to represent the science, and where there's a lack of consensus, it's also important to notice that lack of consensus is okay. Science is all about figuring out how things work. So please, let's get together and have a dialogue about what the studies actually say. With that, I'm over time. Yes, there's a blinking red light, and now I can see it. So I'm going to pass it off, and thank you very much for your attention.